Okay, so let's look at this part 2 of the calculus exam revision. Let's look at question 4a here. Question 4a says evaluate the integral of sine 7x sine 4x dx. Okay, 4ai. So solution there. Question 4ai. So we asked to evaluate the integral of sine 7x sine 4x dx. Now, for questions of this format here, you will need a bit of integral substitution or trigonometric substitution. I've already treated how to solve questions of this kind in our previous class. I'll leave a link in the video description. But then note that if you have an integral of the form sine ax sine bx dx, where a is greater than b, then use the substitution 1 over 2 into the integral of cos in brackets a minus b, this x minus cos in brackets a plus b x, this, and then dx. All right, so you have this. Okay, there's a proof to this formula which I have done in our previous class or in a previous lesson on integration. I'll leave a link in video description. Now, comparing this question here to this form, we can see that in this case here, a is 7 and b is 4. All right, and of course, a is greater than b, so I'll use this substitution. So what that means is that the integral of sine 7x sine 4x this dx is equal to 1 all over 2 into the integral of, open a square bracket here, cosine of a minus b. A is 7 minus b is 4, x minus, next up you now have cos a plus b. A is 7 plus b is 4, then x, you have this, and of course you have dx. Let's simplify this. Now in trying to solve this is equal to 1 all over 2 into the integral of, this gives you cos 7 minus 4 gives you 3. So 3 times x gives you cos 3x minus cos 7 plus 4 gives you 11. So 11x, this into dx. All right, let's proceed with this. Now, proceeding with my solving, this is equal to 1 all over 2 multiplying the integral. Of course, for this, let's look at how to do the integral of this. Now, in solving integrals of this case, or of this pattern here, or before then, let's take them one after the other. So I'll have half times the integral of this and then dx, which is simply half of the integral of, take the first term there, cos 3x, then dx. The sign here is minus, so it becomes minus. Again, you take half and then this and then dx, and that gives you half, this into half the integral of cos 11x, this, and then you have dx, this into dx. All right, so how do you solve questions like this? What do you do? Now this is equal to, again, okay, before then, 1 over 2 half. When it comes to integrating cosine of 3x, how do we solve this? There's a pattern to solve questions of this format, and the pattern is simple. The first thing you want to do is to differentiate cos or integrate cos, please. If I integrate cosine, I'll have sine. All right, integrate cosine, not differentiate. If I differentiate cos, I will have minus sine. But if I integrate cos, I will have sine. So this becomes dot. Integrate cos, you have sine. What I have in brackets here is 3x, so it becomes sine 3x. Now the last step is to differentiate what you have in brackets. What I have in bracket is 3x. Differentiate 3x, you have 3. That becomes your denominator. So it becomes 1 over 2 dot sine 3x all over 3. All right, that's your shortcut. Minus 1 over 2. Let's use the same shortcut here. Again, we said integrate cos, you have sine, so dot sine. Repeat what you have in bracket, 11x. So you have 11x, repeat this. And then finally, all over, differentiate your bracket. If I differentiate 11x here, I will have 11. That becomes the denominator. So I'll have this as 11. So please take note of this, of course, plus c, the constant of integration. C is your constant of integration. So take note of this. This is how you do this particular integration. And this is equal to 1 times sine 3x. That gives you sine 3x all over 2 times 3 is 6. So all over 6 minus 1 times sine 11x is sine 11x all over 2 times 22. 2 times 11 is 22. This then plus c. So basically, this becomes the answer to the question that we were asked to solve. All right, this becomes the answer to the question. So this is how you solve this. All right, but of course, recall how we did this integration. Recall that if I take the integral of cos ax dx, this will give us integral of cos is sine. Repeat the brackets, that's ax all over differentiate ax, that's tell me the bracket. If I differentiate ax, I'll have a. This becomes the answer. So basically, this is like the shortcut for solving questions of this nature. So take notes and then you can use this in subsequent question. All right. Okay, guys, let's see the next question. Don't forget that you can check out our playlist on integration. You'd learn this better. All right. There are lessons on these shortcuts and how to do this in full in the playlist on integration. All right. Okay, let's look at the next question there, 4AII. Okay, so let's look at the next question there. Question 4AII. Evaluate the integral of 1 over x ln x dx. Okay. All right, 4AII, integral of 1 over x ln x dx. So how do you solve this question? For this question here, we'll use integration by parts. All right, so I would say using integration by parts. So how do you solve this question? For integration by parts, you need u, you need du, you need v, and you need dv, as I explained in our previous class. So in this case, you take u as being equal to, now you want to note that whenever you're solving questions involving integration by parts and you have either a ln or a logarithmic function, then u is usually equal to that ln or that logarithmic function. So u will be equal to ln x. Let's get du dx. So du, or simply du dx, is equal to, if I differentiate ln u or ln x, I'll get 1 over x. So to get du, simply differentiate the value of u. If I differentiate ln x, I'll have 1 over x. Next up, we've called this u. The next term there, 1 over x, you call it dv, not v, please. So from here, dv is equal to, that's this 1 over x. I have 1 over x. From here, let's get the value of v. To get the value of v, I'll have to integrate the value of dv, which means integrating 1 over x. And if I integrate 1 over x, I'll have ln of x. So please take note of this. So for your integration by parts, this term here is u, this term here is dv. From here, get the value of du by differentiating this value, get the value of v by integrating this value. All right. you can make reference to our previous class on integration. So check the integration playlist. Go to playlist, check the integration playlist. You see how to solve questions on integration by parts. Okay. All right. So from here, let's use the integration by part formula. The integration by part formula is that the integral of u dv is equal to uv minus integral of v du. Let's impute that value. From here, we'd have that we're taking this as your question, integral of 1 over x. So the integral of 1 all over x ln x, of course, the x is equal to uv, that's u times v. What's u? U is ln x. What's v? V is ln x. That becomes u times v is ln x, right? Yep. That's u ln x uv, so ln x times v ln x. So this is uv, the same value, minus integral, so minus the integral of v du. What's v? V is ln x. So v is ln x v into du. What's the value of du? Du is 1 over x. So dot v dot du, 1 all over x. Now, if you look at this question carefully, you want to see that this term is being repeated. Let me look at this. Here I had integral of 1 over x ln x. I'm seeing the same thing repeated here again. Integral of ln x 1 over x. Of course, this can still be written as the integral of, if I take ln x first, you have ln x, then you have dot 1 over x here. It's equal to ln x multiplying ln x minus integral of ln x dot 1 over x. Of course, even if I don't put the x, we know that I am integrating with respect to x, so the x is not necessary. Now, if you look at this, you want to observe that this term is being repeated here, all right? And this occurs in some kind of questions that involve integration by parts. You now observe that the question gets repeated. So in a case like this, what do you do? In a case where after taking your first round of integration, which is this one here, you now observe that the term is being repeated. As you can see here, you use I. So you say let I be equal to the integral of ln x dot 1 over x. Now you also want to take note that this same thing can happen after your second integration, right? Please make reference to our playlist on integration by parts or integration. Look for the video on integration by parts to learn more about this. All right. So when you take let I be equal to this, what do you have here? All of this one here, this will be called I. Right. So have the I, which is all of this, the integral of this, as we said, I is equal to ln x times ln x gives you ln x all squared. This minus this same thing is the same thing here, and that same thing here, and we call this word there I. So minus I, you have it here. So have this as minus I. All right, that's ln x times ln x all squared, then minus I. Now to solve this, we'll move I over here. So have that I minus I moves over there, becomes plus I plus I is equal to ln x all squared. I plus I is equal to 2I. So you have that 2I is equal to ln x all squared. To get the value of I will divide it by 2, divided by 2. So it means that the value of I, so I is equal to ln x all squared divided by 2. But what's the value of I? We said I is equal to the integral. Look at this here. So I is equal to, this I here is simply the integral of 1 over x, right? Integral of 1 over x, or ln x dot 1 over x, whichever one is the same thing. Let me just write it that way there. Integral of ln x dot 1 over x, which was our initial question, is equal to, the value there is ln x all squared all over 2. Of course, plus c, your constant of integration. So basically, this becomes the answer to that question, and this is how we solve that question. So basically, here is your answer. All right, so this is how we solve this question. Let's move on to the next question. So let's look at the next question here. Question 4bi. 4bi says evaluate the integral of 1 all over root 25 minus x squared dx. Okay, so how do you solve this question? What do you do? The first thing you want to notice is that this is a difference of 2 squared. We know that 25 is the same thing as 5 squared. So we can say that this is still equal to the integral of 1 all over square root of 25 is same thing as 5 squared minus, you now have x squared. So 5 squared minus x squared. Then you add your dx. This is the same thing. Again, for integral of the form, integral of 1 all over root a squared minus x squared, a squared minus x squared dx. For integral of this form, you are to put x as equal to a sine u. That's how you solve integral of this form. Again, I've treated this in a previous class. Please check the playlist on integration. All right. So let's continue with this. So to solve this, we said put x as equal to a. That's this 10 that is being squared, which is 5 a sine u. So we have this. Okay, so what's the next thing you do here? From here, let's try to make u to be subject of the formula. To make u to be subject of the formula, all we have to do is divide here by 5, divide here by 5. This cancels this, so you have that x over 5 is equal to x over 5 would have that x all over 5 is equal to sine u. This equal to sine u. To get u, I'll take sine inverse of both sides such that u will now be equal to sine inverse of x over 5. That's the value of u. Now, having got this, the next thing is to come back to your initial value. We said but x is equal to 5 sine u. If I differentiate x with respect to u, I will have the x du. So the x du is equal to, if I differentiate 5 sine u, what do you get? This becomes 5. Differentiate sine u or sine anything, it gives you cos of that thing. That becomes 5 cos u. So the x du is 5 cos u. Let's get the x. How do we get the x? To get the x, all I have to do is move the u over here. That means that the x will be equal to 5 cos u dot du. This is the value of the x, 5 cos u du. Now, having got this, the next thing we'll do here is to do a bit of substitution. So let's say substituting. If I substitute here, this is equal to the integral. So integral of 1 all over 5 squared minus, next we had there is a squared, root, integral of the square root of 5 squared minus, it was minus x squared. What's the value of x? X is 5 sine u, as you can see here. So in place of x, I'll put 5 sine u. This dot, of course, this squared, this is x all squared. So I'm squaring this dot. So this dot, look at this dot dx. So times dx. What's the value of dx there? The x is equal to 5 cos u. So dot dx is 5 cos u dot du. That's the value of dx, as you can see here, 5 cos u du. Let's simplify this. This would be equal to the integral of 1 all over the square root of 5 squared minus, of course, expanding this bracket here, you're having 5 and squared. That's 5 squared sine u all squared gives you sine squared u dot what I have here, which is 5 cos u dot du. Let's proceed. Now, to proceed to in proceeding to solve this, this will be equal to the integral of 1 all over the square root of, you can see 5 squared and 5 squared, so they can factorize. If I bring out 5 squared here, what I left with? 5 squared here divided by 5 squared gives you 1. So that's 1 here. You have the minus sign. So 1 minus, if I divide this one here, 5 squared sine squared u by 5 squared. Observe that 5 squared will cancel 5 squared, leaving you with sine squared u. So this into sine squared u, this into sine squared u. So check this out. 5 squared times 1 gives you this 5 squared here. 5 squared times sine squared u gives you 5 squared sine squared u. So literally all we have to do here is to factorize 5 squared. That's all. This dot 5 cos u dot du. You have this. Okay, let's proceed with this. Now proceeding with this, let's recall a trig function. All right, let's recall a trig function. Recall something. Recall that sine squared u plus cos squared u is equal to 1. So what this means is that if I move sine squared u over here, we'll have that cos squared u. From here, we can have that cos squared u is equal to 1. If I move sine squared u over to the right hand side, move this over to the right hand side, it becomes minus, so this minus sine squared u. What else? The value of cos u from here, to get cos u, I'll have to take square root. So cos u is equal to square root of 1 minus sine squared u. So whenever you see the square root of 1 minus sine squared u, that's equal to cos u. Now, how does that affect our solving here? This will be equal to the integral of 1 all over. From here, we can see that, of course, if I have a square root term such as root ab, this can be broken down as root a times root b. We can have this. Let's try to separate them. If you separate the terms here, what do we have? That means if you have root 5 squared multiplying this, that becomes root 5 squared multiplying root in brackets 1 minus sine squared u. This is correct. Okay, so you can separate them to have this. This multiplied by what I have here, 5 cos u du. That's 5 cos u dot du. Proceeding further, for this one here, square roots can cancel square, so it's gone. Also, we know that the value of 1 over the value of square root of 1 minus sine squared u is cos squared u, or cos u. Look at this. The value of root 1 minus sine squared u is cos u. So let's impute that value here. This will be equal to the square root of 1 all over. Here I'm left with 5. So 5 dot the value of root 1 minus sine squared u is cos u. So 5 this into cos u dot, I have 5 cos u dot du. Observe that 5 cancels 5 is off. Cos u cancels cos u, it's off. So I'm left with this being equal to the integral of, this is 1 times du here is du. So I have the integral of du. The integral of du is equal to, if I integrate du from this integral cancels differential, I'm left with u. That becomes u as my final answer, of course, plus a c, where c is a constant of integration. But let's go back. Let's go back. But u is equal to, let's go back to the value of u here. Where is that? All right, so you can see here that u is equal to sine inverse of x over 5. So, but u is equal to sine inverse, so sine inverse of x all over 5. So this is the value of u. That means the final answer is equal to, if you have u plus c, it becomes sine inverse of x over 5 plus c. So basically, this becomes the answer to the question. This is how we solve this particular question. Let's look at the next question there. So let's look at the next question there. Question 4b II. The question here says evaluate the integral of x squared plus 6 all over x squared plus 2x dx. All right, how do we solve this question? All right, so here's my question. Integral of x squared plus 6 all over x squared plus 2x dx. How do we solve this? The first you want to observe is that the degree of the numerator or the power of numerator is x squared, which is the same thing as the degree or the power of denominator x squared. And when they are of the same degree, the first you want to do is your long division. What to do your long division here for them? Okay, so I can reduce them. Inside the square root, I'll write my numerator there, x squared plus 6. So here I'll have x squared plus 6. Outside, I'll write denominator x squared plus 2x. That's x squared plus 2x. How do we solve this? You take the first term and this first term here. Divide this by this. So literally, I'm dividing x squared by x squared. If I divide the x squared by x squared, I'll have 1. 1 times everything you have here. So 1 times x squared gives you x squared. 1 times plus 2x gives you plus 2x. At this point, I'm going to subtract. So subtracting them, x squared minus x squared gives you 0. So it's off. Next up, this term has an x. So let's impute that term that has an x. If I look at this term here, I have x squared plus 6. There is no x term here. This is x squared. This is constant. There is no term with x in this particular one here. So assume it to be 0. So the term with x in this case here is 0. So it becomes 0 minus this one here, 0 minus what I have here, 2x. 0 minus 2x gives you minus 2x. So this gives me minus 2x. I'm done with this. There's no constant term here. There's no constant term here. So all you have to do is bring the constant term down. So bring 6 downward here. It's a plus 6. So coming down becomes plus 6. You want to observe that the power here is 2, while the power here is 1. It's now a lesser power. So we can now start solving. Now, how do you write this in terms of a fraction? In terms of fraction, you can say that x squared plus 6 all over x squared plus 2x. This is equal to, you write the term you have here, which is 1. So it's equal to 1 plus your remainder here. You write it this as 2 minus 2x plus 6. Now, I know we have this minus 2x plus 6, but in proper form, we want to take the positive term before the negative. So the positive first gives you 6 before the negative minus 2x. So I'm having this as 6 minus 2x. 6 minus 2x as numerator all over. For denominator, I'll have this term here, which is x squared plus 2x. X squared plus 2x. So I have this. Of course, to complete this, all I have to do is put your integration sign here, dx. It's equal to the integral of all of this thing here, this one here, dx. That's it basically. Now, integrating 1 is not an issue. If I integrate 1, I'll have x. The issue now is integrating this one here. So all I have to do is I'll keep this steady or constant. I'll just pick up this one here. That's where the issue is. So it becomes the integral of 6 minus 2x all over x squared plus 2x dx. To solve this question here, we use integration by partial fraction. And to do that, all we have to do is focus on denominator. My denominator here is x squared plus 2x, which is a quadratic function. I'll have to factorize this. To factorize this, I have x squared plus 2x. If I factorize this, I'll have x squared divided by x is x, so I have x plus 2x divided by x, I'll have 2. So if I factorize that, I'll have x into x plus 2. So let's get our partial fraction form. Again, I've thought how to do this. By do this, I mean I've thought how to solve integration by partial fraction in our previous class. Please check the integration playlist to find the video on how to solve integration questions by partial fraction. Okay. All right, let's continue from where we stopped. From here, the form here will be that the integral of 6 minus 2x all over x squared plus 2x is equal to, this takes a, so I'm having a all over x plus b all over, this takes b, that's x plus 2. For now, let's leave out integral sign. Okay, we just want to get this in partial fraction. Okay, so from here, what do we do? From here, let's multiply the denominator. We'll have that 6 minus 2x all divided by this, all divided by x squared plus 2x is equal to, for this, simply multiply denominator, that's x into x plus 2. If I multiply this, to solve this question here, we'll move this to a, so it becomes a times x plus 2, that's a into x plus 2, plus this goes to b, x times b, that's bx, so plus bx, we have this. At this point, where we have the same thing at denominator and denominator, they're the same thing, just equate numerator. Equating numerator, we have 6 minus 2x is equal to a into x plus 2, this plus bx. Proceeding from here, this will be equal to, this is 6 minus 2x, so I have 6 minus 2x is equal to, let's multiply this, so a times x is ax, that's ax plus, next up, a times 2 is 2a, so that's 2a, and then next up, plus bx, so plus bx. At this juncture, let's collect like terms. If I collect like terms here, we have that 6 minus 2x is equal to, this has x, this has x, it becomes ax plus bx, this then plus this one here, 2a plus 2a. So I'm having 6 minus 2x is equal to, if I factorize the x, take off x here, I'm having a plus b. So I'm having a plus b into x plus 2x. If I compare coefficients, right? If I compare coefficients, look at the constants, or let's start with x. For x, what do we have? For the left-hand side, coefficient of x here is minus 2. Minus 2 is equal to, for the right-hand side, the coefficient of x is a plus b. That's a plus b. Call this equation 1. This is I. Equation I, 1. Now, for constants, let's say k, the constant term here on the left-hand side is 6. So 6 is equal to, for the right-hand side is plus 2a. That's 2a. Call this equation 2, II. From equation 2, let's get the value of a. From equation 2, to get the value of a, we said 2a is equal to 6. To get a, divide here by 2, divide here by 2, this cancels this. So we have that a is equal to 6 over 2 gives you 3. Now put the value of a into equation 1. From equation 1, we have that minus 2 is equal to A. A is 3 plus B. That's A. This one here, 3 plus B. Move 3 over here, becomes minus 2. Plus 3 goes over there, becomes minus 3 is equal to B. Minus 2 minus 3 is equal to minus 5. So minus 5 is equal to B. So with this now, we've gotten the value of A and B. Let's substitute back into our equation here, which is this one here. So that means 6 minus 2x. Let's write this down. So it means that 6 minus 2x all over x squared plus 2x all over x squared plus 2x is equal to A over x. What's A again? You see A is 3. So A over x becomes 3 over x. So A over x becomes 3 all over x. Next up, plus B. So it becomes plus, what's the value of B? B is minus 5. So instead of plus B, it becomes, so you're just saying plus of B, plus of minus 5, right? Plus minus gives you minus. So it's totally minus. So it becomes minus 5 all over, it was B all over x plus 2. 5 all over x plus 2. I am having this particular case. So what next here? We've gotten this one here. The next thing we want to do is go back to the initial question. So from the initial question, we said this is equal to the square root of, or this is equal to the integral of 1 plus this one here. So initially we said it was equal to our value, or the question was equal to the integral of 1 plus this, which is 6 minus 2x all over x squared minus 2x. This dx. This is what we had initially. And this is equal to, if you work on this, this is equal to, let me bring this down instead. Okay. Work on this. This is equal to the integral of 1 plus, we've broken this one here into partial fraction, and we had 3 over x, so plus 3 over x minus 5 all over x plus 2, this into dx. Right, so we have this. 1 is for this. We broke this one down into partial fraction. We had this one here. All right, proceeding. This is equal to, I'll take integral to each of them. That's integral of 1. Then you add dx. The sign there is plus. Again, take integral to the second one there. 3 over x. Then you add dx. Next sign there is minus. Take integral to the next term there. 5 all over x plus 2, then you add dx. All right, so add integral sign, add dx to each of them. Okay, now if I integrate 1 times dx is dx. All right, so take 1 outside. 1 times dx is dx. So if I integrate dx plus, take 3 outside the integral sign, constant should be outside the integral sign. That becomes 3 integral of, I'm left with 1 all over x dx minus, again, another constant 5 outside integral sign becomes 5, the integral of 1 all over x plus 2 dx. Now note that if I'm integrating an x term, if I'm integrating a 1 over x term, such that the power of x here is 1, I'll have ln of what I have there. So this is equal to, from here, integral cancels differential. This becomes x plus 3 into, if I integrate 1 over x, I'll have ln x, of course, because if I differentiate ln x, I'll have 1 over x. So in the same way, if I integrate 1 over x, I'll have ln x. Next up, minus 5. So this is minus 5 into, if I also integrate this will give you ln x plus 2. Reason being that for this one here, the coefficient of x here is 1, and also the power of x here is 1. So you have ln. Okay, so note that. Ln this then plus c. your constant of integration. This is the answer to this question. We've done something like this before now. All right, so go check out our playlist on integration. You see questions of this one here that was solved step by step. But in this case, I'm just trying to solve the past question, so I'm a bit faster. Do well to check the playlist on integration so you see a step by step approach to this question. But basically, this is the answer to the question. Let's look at yet another question. Okay, so let's look at question 5a. Question 5a says, find the equation of a tangent and normal to the curve y squared plus x squared plus 4x plus 6y equals 0 at the points 3 and minus 5. Now let's write this down first. So solution, question 5a. So we were given y squared plus x squared plus 4x plus 6y, it's equal to 0. Just construct this. All right, we have to find the equation of the tangent and normal to a curve. So how do we do that? The first thing we want to do is to differentiate 2y. This would be an implicit differentiation. If I differentiate 2y, that gives you. So the first thing we want to do here is to differentiate y squared. If I differentiate y squared, it gives you 2y. That's implicit differentiation. So you have 2y. Whenever you differentiate y squared or a y term, you add dy over dx. Whenever you differentiate a y term, plus if I differentiate x squared here, you have 2x, no dy dx because you're differentiating an x term, plus differentiate 4x here, that gives you 4, that's 4, plus differentiate 6y, you have 6, you add what's there, you add dy dx, of course, equal to, I'm having 0, differentiate 0, you have 0, that's 0 here. We want to take all the terms having dy dx, we want to leave them on the left hand side. So the terms having dy dx, this one here, you have 2y into dy dx, and then this one here, you have plus 6 into dy dx is equal to, move this over to the other side, so it becomes minus 2x, move this also over to the right hand side, becomes minus 4. So this, right, so you have this. Next up, let's factorize dy dx. If I factorize dy dx, that means if I take dy dx here, what do you have? I'm left with 2y here, so 2y plus this one here plus 6, 2y plus 6 is equal to minus 2x minus 4. You have this. Let's get the value of dy dx. To do that, I'll simply divide here and also divide here by 2y plus 6. Okay? Also divide here by 2y plus 6. You have this. So this cancels this. And hence you have that dy dx, it's equal to, what I have here is minus 2x minus 2x minus 4 all over, so this all over 2y plus 6. So I have 2y plus 6. Let's take at the points. At the points there, what point am I given? At the point, let's see from the question there. I said at the points 3 and minus 5. So at 3 and minus 5. When we have at 3 comma minus 5, what does it mean? It means that the value of x is equal to 3 and the value of y is equal to minus 5. So put x as 3 and y as minus 5. What do you have? You have that dy dx is equal to, this is minus 2x, that's minus 2 into x, x is 3. Then you have minus 4, so this minus 4 all over you now have 2y plus 6 becomes 2 into y is minus 5, 2y plus 6. So you have this. All right, let's get our value. I'll just go straight to get the final answer here. So you can use your calculator and punch all of this and see what your final answer give. Okay, so minus 2 times 3 minus 4 all over 2 into minus 5 plus 6. So if you punch this correctly, your final answer will give you 5 all over 2. That's your final when you punch this correctly. What you have here is called the slope of the tangent. All right, this is called the slope of tangents. Note that. So the first thing you get here is called slope of tangent. Okay, now let's proceed with this. To get the value of we have to find the equation of the tangent. Note that the equation of the tangent is given by y minus y1 is equal to m1 into x minus x1. So you're having y minus y1 is simply equal to, let me show you this y value. We are given 3 and minus 5. Y1 is equal to this value here. So y minus y1 is minus 5. Y minus y1 is minus 5. It's equal to m1 is your slope, which is 5 over 2. That's 5 over 2 into x minus x1 is, where is this? This one here, which is 3. Which is 3 here. All right, working on this, this gives you y minus minus 5 is plus 5 is equal to 5 all over 2. Of course, x minus 3 multiplies numerator. That becomes 5 into x minus 3. This all over 2. Now to solve this, all you have to do is cross multiply. This 2 goes this way. That becomes 2 multiplying y plus 5 is equal to 5 into x minus 3. Multiplying this, 2 times y gives you 2y plus 2 times 5 gives you 10 is equal to 5 times x gives you 5x minus 5 times 3 gives you 15. So this into 15. Let's get the value of y. You have that 2y is equal to 5x minus 15 plus 10 goes over here becomes minus 10. 15 minus 10. You have this. So now have that 2y is equal to 5x minus 15 minus 10 gives you minus 25. That's minus 25 from here. To get your value of y, we'll divide here by 2, divide here by 2, divide here by 2. So from here, we can say that this cancels this. So y is equal to, this is 5 all over 2x minus 25 all over 2. So what I have here becomes the value of, this is the equation of the tangent. Remember, you asked to find equation of tangent and normal. So what I've just got here is the equation of the tangent. So I've gotten equation of the tangent. All right, equation of tangent. We've got that. Let's now get for normal. For normal, once you get the equation of the normal, for normal, the first thing you want to note is that the slope of the normal is called m2, and m2 is simply equal to the negative inverse of m1, where m1 is the slope of the tangent, and that's equal to negative inverse of the first slope. Going back upwards, what's your first slope there? The first slope is this is the value of m1. All right, that's m1. This is the value of m1. So m1 is equal to this 5 over 2. Okay, so I'll come here, minus 1 all over here, 5 all over 2. And this is equal to solve this, just take this, take this upside down. That becomes, okay, Now, to simplify this, all you have to do is you take this upside down, and that becomes 2 over 5. The minus sign here, so it becomes minus 2 over 5. That means you have y, repeat the same process, y minus y1. In this case, is equal to m2 into x minus, well, if you want to use x2, that works too. So for normal, we can say y minus y2 is equal to m2 into x minus x2. I'm still taking the same position of 3 and minus 5, where y is minus 5 and x is 3. All right. So we can now say at that same point, we're given 3 and minus 5. What do we have? We have y minus, what's y2? Y2 is the value of y here, which is minus 5. Minus 5 is equal to m2. What's the value of m2? This one here, minus 2 over 5. That's minus 2 over 5 into x minus x2 is the value of x here, which is 3. So I have this. Let's proceed with this. From here, y minus minus is plus, so I have y plus 5. Okay, so I have that y plus 5, it's equal to, this gives you minus 2 over 5 minus 2 over 5 into x minus 3. This into x minus 3. All right, to solve this, I'll move 5 over here. That becomes 5 multiplying 5, y plus 5. It's equal to minus 2 into x minus 3. If I expand the bracket here, 5 times y is 5y plus 5 times 5 is 25. It's equal to minus 2 times x is minus 2x. Minus minus is plus, 2 times 3 is 6. So I have this. Proceeding from here, we'll have that 5y, it's equal to, this gives you minus 2x plus 6 minus 2x plus 6. Next thing here is I have plus 25. Move it over here, becomes minus 25. So this is minus 25. From here I have 5y, it's equal to minus 2x plus 6 minus 25 gives you minus 19. All right, that'll give you minus 19. So I have minus 19. From here, to get the value of y, divide here by 5, divide here by 5, and divide here by 5. So this cancels this. So I have that y. This gives you y is equal to, what I have here is minus 2 over 5x minus 2 all over 5x, and then minus 19 over 5 minus 19 all over 5. So I have this one here. This thing I have here becomes the equation of the normal. That's equation of the normal. So basically, this is how we solve this particular question. Let's look at yet another question. Let's look at question 5b. On the question here says, find the maximum and minimum points of the function y equal to, is a minus here, minus x cubed plus 4x squared minus 3x plus 3. Find also the minimum, the maximum and minimum values of the function. All right, let's get this done. Question number 5b. So you're given a particular function there, that's y, it's equal to minus x cubed plus 4x squared minus 3x plus 3. Now, to solve this, we would have to use something called the second derivative test. Before we do that, let's first of all get the value of dy dx. Dy dx here is equal to, if I differentiate minus x cubed, I'll have minus 3x squared. Next up, plus If I differentiate 4x squared, you have 8x squared minus, if I differentiate 3x, I'll have 3. Then constant, differentiate 3, you have 0. So that one is off. So you have this. You want to find something called turning point for the turning points. And for the turning points there, the idea or the condition is that the derivative dy dx should be equal to 0. That means you equate this function to 0. So simply, I'm taking the function minus 3x squared plus plus 8x, then differentiate minus 3x, you have minus 3. So minus 3. So you have this, of course, differentiate plus 3, that's 0. So it's off. Okay, from here, you're having that dy dx is equal to, if I, at this point, the next thing you do is to take the turning points, all right? Take turning points. So look at the condition of something called turning points. For turning points or at turning points, you have that dy dx is equal to 0. That's the condition for the turning point. So what that simply means is that I'll equate this function to 0. So minus 3x squared plus 8x minus 3. You equate this to what? 0. Right? So equate it to 0. Now, if I equate this to 0, this becomes a quadratic equation that I have to solve. All right? So let's solve this quadratic equation. Depending on the method you want to use in solving the quadratic equation, all right, for me, I'm just going to use a calculator to give me the answer very fast. But if you want, you can use either the formula method or factorization or any method that is suitable for you. Then if you solve this quadratic equation, you have that x is equal to, you have your answer as 2.2, 2.22, or your second answer would be in decimal 0.45 or 0.45. All right, so use any of the suitable method of solving quadratic equations. For me, I'm using a calculator and I have these answers. Now, when you're done with this, what next? You put this value, put the value of x into y. That's the next task there. So put the values of x into y. If I put the values of x into y, what do you have there? From here, we have that y is equal to minus x cubed plus 4x squared minus 3x plus 3. You have that y is equal to minus x cubed plus 4x squared minus 3x plus 3. At x equal to, so at x equal to the first point we have here is 2.22. At x equal to 2.22. What's the value of y? You have that y is equal to minus x cubed becomes 2.22. That's x cubed plus 4 into x squared. X is 2.22 all squared minus 3 into x, 2.22. Then finally you have plus 3, plus 3. So putting that value there, what do you have? You have that y is equal to, I will use a calculator to punch this and get my answer real quick, minus 2.22 all cube plus 4 into 2.22 all squared minus 3 into 2.22, then plus 3. Close this, then plus 3. If I work on this, this will give me about 5.11. So I have this as 5.11 as your answer, 0.11. So that is at x equal to 2.22, y is 5.11. All right, 5.11. This value you have here is your first result. Call this A. That's your first point. Now let's look for the second point. That's at the second point is at x equal to, what's my second point there? At x equal to 0.45, this one here. So at x equal to 0.45, 0.45, let's find the value of y. Y will be equal to, again, whenever I see x here, I'll put 0.45. So this becomes minus 0.45 cube. So minus 0.45 cube. Next up, plus, you have plus 4x squared. That's 4 into x squared. 4 into, what's x squared there? 0.45 x squared. Okay. Next up, you have minus 3x. So minus 3, x is 0.45. That's minus 3x. And then you have plus 3. So you have plus 3. So plus 3. So let's impute this value. If I impute this, you have that y is equal to, so minus 0.45 squared cube plus 4 into 0.45 squared, 0.45 squared minus 3 into 0.45. Let's see, minus 3 into 0.45, then plus 3. Your answer gives you about 2.37. 2.37. That's your answer. That is the second point, is that at x equal to 0.45, y equal to 2.37. You have this. So what you have here becomes part B, or point B. This point B. Now, out of point A and B, one is a maxima, one is a minimum value. How do we get minimum and maxima? We use second derivative tests. So we say using second derivative tests. Now we have the value of dy dx. To get the second derivative, we'll have to differentiate the value of dy dx. So this value here will differentiate the value of dy dx. And if I do that, differentiate minus 3x, but you have minus 6x, plus differentiate 8x, you have 8. So the value of the squared y over the x squared is minus 6x plus 8. So the squared y all over the x squared is equal to minus 6x plus 8. All right, so with this, I'll put the value of x here. So at the first point, at A, for A, we have that the value there, the point there is 2.22, 5.11. At A, 2.22, 5.11. You have this. We have that the squared y all over the x squared is equal to minus 6x. The value of x is here is 2.22. So minus 6 into 2.22, that's x, then plus 8. So you have this plus 8, and that's equal to, so I'll punch this real quick, minus 6 into 2.22 plus 8. If you punch that, your answer is minus 5.32. Now you have to note that if the value of the squared y over the x squared is negative, as you can see here, what you have there is a maxima or maximum value. So this is maxima, that's the condition. If the squared y over the x squared is negative, it is a maxima slash maximum value. Take notes. Next up, let's see the next point there. At second point B, what's B? For B, the points there, let's see again. B is 0.45, 2.37. 0.45, 2.37. 0.45, 2.37. What's the value of the squared y over the x squared? We have that the squared y all over dx squared is equal to minus 6. Look at this. It's minus 6x. Minus 6x. X in this case would be this value here, 0.45. So minus 6 into 0.45, that's minus 6x, and then plus 8. So plus 8. I'll just go ahead and punch this. Minus 6 into 0.45 plus 8. This gives you a positive answer. So the answer is positive 5.3. All right. When you have a positive answer of the squared root over the x squared, what you have there is minima. You have a minima, also called a minimum value. All right. So we've gotten this. So when they say we should get the, what's the question again? Let's go back to the question here. When they say we should find the maximum and minimum points, we've done that. And also find the maximum and minimum value of the function. So we've already done that. That means the maximum value, maximum function, or maximum points, right? Let's use their term. They say we should find the maximum and minimum points. All right. Maximum point of function. Let's see. Therefore, maximum points is, what's a maxima there? The maxima there is 2.225 points. That's about 2.225.11. That's the maximum points. Let's get for minimum points. Minimum point is, what's the minimum point? Minimum point here is 0.45, 2.37. 0.45, 2.37. I've gotten this. So that's the value of the maximum point and the minimum points. They said we should also find the maximum and minimum value of the function. I think find the maximum and minimum values of the function. Yes. Now to get that, in fact, you've already gotten that. The maximum value of the function, the maximum value, this value, let me write this better. Maximum value of the function, maximum value of the function is the value of y at the maxima. So at the maximum point, the value of y there's 5.11. That's your value. So go to the maxima, get the value of y, 5.11. Also, similarly, the minimum value, of the function is the value of y at the minimum point or the minima, which is 2.37. So basically, this is how we solve this question. All right. Let's look at the next question. Okay, so let's look at the next question there. Question 6a says, evaluate the integral, the definite integral of x exponential x squared, upper limit 1, lower limit 0. Now, we've already solved this question here in a previous class. I'll leave a link in the video description. So check video description to see the link to this particular class. Let's look at 1a. Find the area enclosed by the curve y equal to x squared and y equal to 5x. So how do you solve this question? We'll just go and write question 6a. So question number 6a. How do you solve this question? Now we're asked to find the area enclosed by the curve y equal to x squared and y equal to 5x. How do we solve this question here? Now, to solve this question, the first thing you want to do is to equate y to y. Like literally, y is the same thing as y. And if I equate the terms, the first y represented x squared is equal to the second y represented 5x. Now, all I have to do here is to move 5x over to the left hand side. So you have x squared. 5x moves over to the left hand side, becomes minus 5x is equal to 0. At this point, we know we can factorize x. So factorize x there. X squared divided by x gives you x minus 5x divided by x gives you 5. This is equal to 0. So from here, obviously, we can say that, take the first one here, x is equal to 0. So x is equal to 0, or take the term in bracket there, x minus 5 is equal to 0. And if I solve this, you have that x is equal to minus 5 crosses over, it becomes plus 5. So we can say that x is equal to 0 or 5. 0 becomes the lower limit and 5 becomes the upper limit. So hence, the required area from here, we can say the required area, the required area is the integral 5 upper limit, 0 lower limit of the function. The function we had was this one here, x squared minus 5x. So have this into x squared minus 5x. Of course, we are integrating with respect to x, so dx. Okay, so how do we solve this question? Now, all we have to do is just focus more on the term in the brackets. So I'll look for how to get the integral. All right, I'll get the integral of, let's ignore the limits, the upper and lower limits. I'll just look for a way to get the integral of x squared minus 5x dx. Let's get this limit here, or let's get this integral. This will be equal to solve this, just take integral sign to the first one, that's integral of x squared, add your dx, then take integral sign to the second one there, that's minus the integral of the second one there is 5x, add dx. So you have this. All right, so integral of each of them, that's for x squared add dx, minus for 5x add dx. Let's integrate this. What do you have here? The integral of x squared is simply x. We said to integrate, just add 1 to the power, so 2 plus 1, divide by what you have there, that's 2 plus 1. So I have this minus, if I integrate 5x, take 5 outside the integral sign, you have 5. If I'm to integrate 5x, the first thing you want to do is take 5 outside the integral sign, so 5 integral of x. To integrate x, the power here is 1, so add 1, that becomes x to the power 1. You add 1 to it, 1 plus 1 all over 1 plus 1. Right? So this is equal to x into 2 plus 1 is 3. This all over 3 minus 5. X into 1 plus 1 is 2 all over 2. When you're done integrating, normally you should put plus c, constant of integration. But when you're doing definite integrals, you don't have to put in the plus c. It doesn't matter. Just put in your integral instead. So this, just put in your limit. The limit is, upper limit is 5, lower limit is what? 0. What does this mean? This is equal to, so all I have to do here is to repeat this particular function here. So it becomes, if I'm repeating this, it becomes, wherever I see x, I'll put the upper limit as 5. So x cubed becomes 5 cubed. I'm having 5 cubed all over 3 minus 5 into x squared becomes 5. So 5 into 5 squared all over 2. So you have this, put x as 5. Then take minus, that's how you take definite integral. So minus, repeat the same process, but wherever you see x, now put 0. So the task is simple. Put x here, substitute the value of x here as 5, then subtract, that's minus, do the same thing, substitute the value of x as 0. So this becomes 0 cubed over 3. So into 0 cubed all over 3. Okay. Minus 5 into, so minus 5 into x squared. X is 0 squared all over 2. So you have this. Okay, let's get this done. This is equal to, I'll get my calculator and I'll punch the value of 5 cube all over 3. Let's see what we get. So I'll get calculator there. 5 cube is 125. That's 125. What you have here. 5 cube is 125. This all over 3 minus 5 times 5 squared is 5 cube. That's 125 all over 2 minus, for this we don't have to stress, 0 cube is 0 over 3. This gives you 0 minus 0 squared is 0 times 5 is 0 over 2. That's 0. That means everything here, this one here, will give you 0. So don't stress about it. So minus 0. Don't stress about it. Use your calculator there. Punch 125 divided by 3 minus 125 divided by 2, and that will give you about minus 125. This is equal to negative 125 all over 6. All right, that's my answer. And this will be in square units. Why is it square? Well, because we are looking for area. That's what we ask to find, area under the curve or bounded by the curve. This now, area is not supposed to be negative, it will be positive. So that becomes 125 all over 6. And say square units. Area is supposed to be positive, not negative. So if I have a negative area, what does it mean? It means the curve is going downwards. All right. That means it is covering a negative region. That's downwards. So that's why you're having this. All right. So it becomes 125 over 6 square units downwards. So this becomes the answer to the question. All right. So that's how you solve this question. All right. Let's look at the last thing there. Last question. Let's get this last question here. Find the area of the surface of revolution generated by the arc y equal to 4x cubed between x equal to 0 and x equal to 1. That's your question. So how do we solve this question? So final question, question 6b. Question number 6b. How do you solve this? The first thing there is that you're given y as equal to 4x cubed, and you're given at x equal to 0 and at x equal to 1. All right, so how do you solve this? Now, in solving this question here, you want to take note that for this question here, you want to take note that the formula for finding area A is equal to the integral of the limits, all right, which are x equal to 1 and x equal to 0. That's x equal to 1, that's the upper limit, and 0 lower limit. And the formula there is 2 pi y into the square root of 1 plus the y over dx all squared. You have this squared dot dx. So this is the formula to solve this question. So looking at this formula here, you can see that I need a value for the y over dx, this one here. So let's get the y dx. If y is equal to 4x cubed, we'll have that dy dx is equal to 12x squared. So when we now say this one here, when we say dy over dx all squared, so if we say dy dx all squared, that's simply equal to 12x squared all squared. That's it. 12x squared all squared. 12 squared is 144. That'll give you 144. X squared is x power 4. So we have this. All right, let's substitute. Substituting. If you substitute, you have that area A is equal to integral of 1, 0 into 2 pi y. That's 2 times pi times y. What's the value of y? said y is 4x cubed as given in the question. Y is 4x cubed, 2 pi y, square root of, so this into the square root of 1 plus, so 1 plus the value of this, the y over the x all squared, which is 144x power 4. 144x power 4. So this and then dx. All right, let's simplify this. So a will be equal to the integral of 1, 0. 2 times 4 gives you 8. And then take your x cube. So 2 times 4, 8. Take this one here. 8x cubed pi square root of 1 plus 144 x to the power 4. Of course, dx there. All right, let's solve this. So how do we evaluate this integral? What do? We use substitution here. We say let u be equal to the term inside the square root sign. That's 1 plus 144 x to the power 4. Let's get du dx. Du dx differentiating. Du dx is equal to, if I differentiate 1 here, constant gives you 0. Differentiate 144x to the power 4. Now to do that, all I have to do is multiply 144 by 4. That becomes 144 times 4, which is 576. So 576 x to the power 4 minus 1 is 3. All right, so I have this 576 x to the power 3. Let's get the x here. How do you get the x here? These two can swap position. This one goes down, the x goes up. So you have this, you have that du all over. Coming down, we have 576 x cubed is equal to, this is equal to, the x goes up, you have what there? Dx, that's the value of dx. All right, let's substitute. Substituting, what do I have there? I have that for the meantime, I'll ignore the integral and just work with, I'll ignore the limits and just work with the integral. So I have the um, integral of 8x cubed, 8x cubed pi into the square root of 1, square root of 1 plus 144x cubed, we call that u, so it becomes u. So all of this becomes u, so it becomes root u dot dx dot, what's dx? Let's go back to this part here. Dx is du over 2 576 x cubed. So you have this. From here you can see that x cubed will cancel x cubed. So x cubed cancels x cubed. Let me see, 576 all over 8. 8 here, 1, 8 here, 72. To become 72. So basically this would be equal to the integral of pi root u, that's pi into root u dot du over 72. So dot du all over 72. Now what I want to do here is that I want to move all the constant term outside integral sign. My constant term here is pi. I have pi as a constant term all over, have denominator 72, integral of root u dot du. So you can see the way I did this, right? Move the constant term outside integral sign, you have this. All right, let's proceed from here. From here, let's integrate this. If I integrate u, what do I get there? This is something I'm saying this is equal to pi over 72 into the integral of root u is u to the power 1 over 2. And to solve this, that becomes pi all over 72 into the integral of this becomes u to power, the power there is 1 over 2. To integrate, you add 1 to the power, so plus 1 all over 1 all over 2 plus 1. So you have this I have this case here. Now at this point, you can now bring back the value of the limits. We had limit as 1 and 0, so 1 and 0. So you can see how we did this. Okay, you solve this. When you're done, you now bring in the value of the limit. This is equal to pi all over 72 into, this becomes u to power. This gives you about 3 over 2, 3 over 2 all over 3 over 2. We have this into 1 and 0, and that's equal to, now if you want to simplify this, okay, let's simplify this. This is equal to, what I have here is simply pi all over 72 into, let's simplify what I have here. If you have u to power 3 over 2, you have this as divided by, so divided by, divided by 3 over 2, divided by 3 over 2, as you can see here. Now to solve this, this would be equal to u to power 3 over 2 times inverse this, right? Becomes 2 over 3. So what I have there is 2 over 3. This into 2 over 3 u raised to power what there? 3 over 2, right? Yep. To power 3 all over 2. We have this. The limits there are 1. The limits there are 1 and 0. From here, I think 2 here, 1. So look at 72 divided by 2. That's about 36. 2 here, 36. Okay. Proceeding with this. This is equal to pi into this 3 will multiply 36. Want to bring it outside there. 36 times 3, that's about 108. Pi all over 108 outside integral sign. I'm now left with this one here. That's u to power 3 over 2. 3 over 2. My limits there are 1 and 0. So to solve this, this is simply equal to pi all over 108 into, put u as 1. So this into put u as 1. The first is 1 to the power, there's 3 over 2. That's u to power 3 over 2. Then minus, put in the second limit. So put u as 0 now. That's 0 into power 3 over 2. I have this. Of course, 1 raised to power anything is 1. This is equal to pi over 108. 1 to power anything is 1. That gives you 1 minus 0 to power anything is 0. Of course, any positive thing or negative thing. So far as it's not 0 to power 0. All right, so from here, this is equal to pi all over 108 into 1 minus 0 is 1. And this is equal to, the value here is equal to pi all over 108. This becomes the answer here. All right, so that's the area. So the area, therefore the area A is equal to pi all over 108 square units. All right, it's an area to be in square units. So you can stop here, or if you want to put the value of pi, you can put that value there, but you can stop here. This is still correct. All right, so with this, we finish the question. All right, so if you enjoyed this video as usual, make sure you hit the like button, like this video, leave a comment. If you enjoyed the video, tell us you enjoyed this in the comment section. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload new content. Then finally, share this video to your friends so that they can also learn. Thank you and see you in our next class.